All right. Let's just get going with the project real quick, since we want to get that organized. So I put up a thing with project rules. So starting from next week, instead of turning in the homework, you're going to be turning in these things. So we need to get those projects formed. Email me preferences for team members and projects by tomorrow night. So just send me a list of the names of anyone who you might want to work with, and there's a list of projects that you'll see in a few minutes, and which of those you would like in descending order of life, or relax, sit back, and do absolutely nothing, and then I will put you together into a team with other people who are equally relaxed, and you will probably end up getting the most popular project. That's the way it goes. So we have teams of 3 to 4 people. That means that every project is going to be one or two people, about 1 or 2 teams. So there'll be some duplication, but hopefully not too much to keep it interesting. You have to write an individual report once a week. And so the way I want you to do it is just imagine that you were a contractor. So if you contract out your time, then it is important for you that you record every minute of it. So I do that once in a while. Like sometimes I have some attorney or someone who wants to hire me for some expert witness stuff, and then I send them a bill, just like an attorney does, and so they perfectly understand that, where it says the day from 10:20 to 10:35. Phone call with time. I bill for my time. If I talk to them, that's my time. And so you just write it up. It's really good practice because one day you will do this, very likely. And so it's just a habit you want to get into. Just have a text file open somewhere, and whenever you've done another 20 minutes or so, just add it on there. And you'll notice gratifyingly that those hours add up fast. Just imagine if you pay yourself $200 an hour. And so then you'll enjoy doing this one. And I want to know at each week what's the total hours that you've worked this week, and then the accumulated total hours in the entire project. And so you will be surprised how it adds up or not, whatever the case may be. So you just turn these things in once a week, and if you like, you can add whatever comments you want. If there's some issue in your team that you want me to know about, or if you're particularly proud of something and you want to present something, or whatever it is that you might want me to know, or if there's some problem that you have and for some reason you didn't send me an email. Everything, so this would happen in your personal repo. Just make a subdirectory project and put those in there. Everything else happens in the team repo. So each team needs to go to Bitbucket or GitHub and make a team thing. Leave it private. If later at the end of the semester you really love the way it came out, then of course you can make it public. But right now, play it safe, leave it private. Add me and the grader to it so that we can see what you do. So any documentation that you want to have, and so I hope that you will come up with some documentation. I don't know, once in a while ask for some. You put it in the wiki that Bitbucket and GitHub provide. So if you've never used the wiki, it'll take you 15 minutes to learn how to use it, but it's obviously not rocket science. So in terms of beauty, and the whole idea of a wiki is that contents wins over beauty, that you just dump into content so that it's readable. And it also means that other people can quickly edit it if there's some update that's necessary. And that's just fine. So all documentation, all of your code lives in Bitbucket or GitHub. Now imagine that you're in a team with 3 or 4 people, and now you're working on something, and you find out that the documentation written by someone else is wrong or misleading. What do you do? So he said, tell them to update it. What do you do?
Tell them to update.
You fix it right then and there. You go into the wiki and you just change it. What if you did it wrong? Well, then you can always undo it, right? It's a repo. It has the old version of the thing. So the entire idea, and if you've done teamwork before with GitHub, then you know this. But if you haven't, then it always comes to a surprise to students. Is that the entire idea is that it's better to ask for forgiveness later than for permission now. If there's a change that you need to make progress, you make the change. If there's some code where, like the user, where say the class interface is so that you can't actually use the class, but it's really easy for you to fix it up so that you can move on, change the class even though it wasn't yours. What's going to happen? I mean, the other party is most likely not going to complain for you doing some of their work. So you move a lot faster if you allow yourself that freedom. And what's the worst case? The worst case is that they really hate what you're doing, and then you get together and you fix it up. What that likely means is that, because people will do this, that when you make changes locally, other people might have made changes to the file that you are using. And then when you push, it's going to say, well, don't push, you have to pull first. You know that part because that happens whenever I add something to your wiki, which is why I wanted you to practice that. Well, what might happen now is that both you and someone else change the same file. Does any of you know what happens then? No, it doesn't. No. It'll create what's called a merge. First of all, that's actually not true. In 99 out of 100 cases, it will silently merge the changes together because they happen in different parts of the file. One of you might have changed one method, someone else might have changed another method, and it'll just merge the two together. And most people will never notice. I've been working with lots of people on large repos, and it is amazing to me how often when I say pull, I get a bunch of messages that say this or that has been merged. I don't even look. At the very first, I was very curious and said, what the heck was it doing? But now I don't even look. If some problem arises, I'll find out soon enough what some test fails. And once in a while, when the automatic merge algorithm can't figure it out because people were working at the exact same spot and it can't figure out which one is better, then you get a merge conflict. The very first time you get it, it's kind of scary, and then you have to read up on how to deal with a merge conflict. But after a couple of times, you also learn that part. It's not particularly difficult. You just get both versions of it. You need to resolve them, and then I can't ever remember the magic commands either that you have to issue and I guess Google forget that. It happens so rarely that I don't even bother to write them down on a cheat sheet. All right. The other thing is work assignments. So when you're going to meet, probably either in person or virtually, whichever way you want to do it, and you have to make it so that each of you has tasks. Now, if no one's given you any tasks because somehow the team is semi-dysfunctional, which does kind of happen a lot with student teams, then you need to give yourself some tasks. You put those tasks into the issue tracker. Both Bitbucket and GitHub have an issue tracker. I'll show you what the Bitbucket one looks like.
Quick question on that.
Yeah.
Is that like a folder we're supposed to create in our project, or?
No. Okay, let me just go there and I'll show you one. And I'll do it in Bitbucket because that's what I use more. Like I have a student who's working with me on some project right now, and so here it has a thing called Wiki, and here I just made this thing yesterday. So one of these buttons, this button I believe is Wiki here, this is the one here. And I put the build instructions on what he needs to do to build this thing. And the way you do that is you click on Edit. There's an Edit button here somewhere. I guess I need to log in. Okay, I'm not going to do that because I can't remember my password for this thing. No, I don't. In GitHub, there's a wiki somewhere. Yeah, you down here. Oh, when you make the project, you have to say you want a wiki and you want an issue tracker. So pay attention to that when you make that project for the first time. I don't know if you can later turn it on. And then you might also have to say that you want it publicly reviewable or something. You'll figure it out. You're going to add it afterwards? Great. And so somewhere here, I don't have that on this one here, but I have it on another project where I have an issue tracker. Is this the right one? Yep. And somewhere here, there'll be issues. Hey. Here. And so there's some issues here. These are ancient because no one has ever done anything with this particular thing. But there's a way of making a new issue. Each issue has an assignee, and that's the person responsible for it. So you break up your weekly things into some tasks. You put them into the issue tracker. And then whoever is assigned at some point is going to close the issue when they're done with it. What I will periodically do is I will see what issues people are working on. At the end of the semester, when I need to assign grades, I will look at all of the issues that you were working on, and that tells me what it is that I should be grading. If it's not in the issue tracker, you're not going to get credit for it. So it's in your interest to put every fiddly-poo into the issue tracker. That's what people do. So if there's something that you need someone else to do, feel free to make an issue for them. They'll be grateful that they didn't have to do it themselves, and then they get credit when they close it. So the typical workflow is that every once or twice a day you look into what's in there in the issue tracker. That's your responsibility. You work away and close it. If you find that other people need to do some work, you put that into the issue tracker. It's something that's a really useful work habit to know, and that you're going to be doing many times in your life. And particularly when you're working on a strenuous project, the issue tracker kind of is your life. So those are the couple of things that you want to be able to do here in GitHub Bitbucket, and that's the only place that I look at. I'm not going to look at documentation anywhere else. I'm not going to be looking at what your accomplishments were anywhere else. And that way we all look at the same place. Every Thursday, each team is prepared to give a presentation. We won't have time to have everyone give a presentation every time, but I will randomly pick one of the teams, starting with the back row. Just randomly pick one. And so one or two teams will give a quick presentation as to where they are. Now here's the most important part, that when you have something that where you have a short fuse, we have 6 weeks to get this whole thing done. The only way to get it done is to have code that always works. That's always there, that always compiles, that always runs, maybe with some errors. And so what you're going to have to be doing by next week is to put in some starter code from somewhere for your project that compiles, that runs, and that anyone can build by checking out your repo into some trash directory and then running the build script. So how you run it, that kind of depends on what it is. If you're using, if you're doing something with Android, you're likely going to be using Gradle because that's the build environment that they have, or maybe just a bash file that kicks it off if you don't want to mess with it. And if you're using MyViolet, you're going to be using the Ant script that's in there. Now, I know you don't know how Gradle works and how Ant works, but I hope that Stack Overflow will get you going. If not, put questions on that and I'll tell you. So I expect that one person in each team is going to have to task over the weekend that says, get an initial build script to run. I don't expect very much. I just expect that it compiles and runs something. But I do want to see the build script. All right, so it's what's important, of course, is that the build script can run on any machine. What are the 6 most scary words that a software engineer can say? Oh, it's an important trivia fact. The 6 scariest words out of the mouth of a software engineer are, but it builds on my machine. Right? Because that means that that it's useless in a team project, right? Who cares whether it builds on your machine? Of course it builds on your machine, right? The question is, does it build on my machine and everyone else's machine? So it is important that we, from the get-go, have a system where anyone at any time can check out what's in the repo and build. Typically, what happens, and we're not going to be able to get to that level of automation, but typically what happens is that every 15 minutes, some automated process checks out what's in the repo, builds it, and sends an email to the knucklehead who broke the build. That really is what happens. And if you might get an email at 3 a.m. if you work on an internationally done project that says, because of something that you did, the build was broken. So it has to continuously build. That sounds crazy, but you'll see it works just fine. So I give you a bunch of projects. You can read through them and just kind of throw darts at it and see. They're all doable. They all look like they're not doable. I will give you plenty of hints. So I will meet with the individual teams in some way and give hints on where to start and what to do. There will be no more homework for the rest of the semester, so you will have plenty of time to do this in lieu of homework. So your homework is to carry this project on. So there's some week 1 goals. So I want to make sure that there is some wiki document that describes what you think you're going to be implementing. Is it going to have anything to do with reality 6 weeks later? No. But you're just putting an initial stake on saying, we think we're going to be implementing these features. I want you to figure out amongst each other who is going to be doing what in the coming week. Keeping in mind that there are only 5 more weeks. So don't underload yourselves. I want to see that there is code in Git. So if you're starting out with, let's say, Violet 016, you just put Violet 016 in Git and maybe make one change somewhere and have some build instructions so that someone can build the thing on the command line. If you're starting out with Android, you don't know anything about Android programming yet, so it's going to take you a bit to come up to speed. And so then you just put some basic Android project that seems to be drawing a rectangle or something that seems to be vaguely related. There's a bunch of sample projects that are in the SDK. Same thing with JavaFX. It's going to take a while to do that, so you would just get started with something basic. Yeah.
Can the Android project be done on an Android phone? Is there like a simulator?
There is a simulator. Oh yes. Yeah. And the hope would be that some people in the team, I would say if you have a team with 3 people who are all iPhone users, that might not be the best team for the Android project. So yes, so try to get someone who has an Android on the team. So if that means if you're emailing me and say I'm interested in the Android thing, tell me if you have an Android. Okay, so that I can make sure that that's the case. That's all. Any questions about how the project is going to kick off? Yes?
How the project's going to create a whole, like in terms of requirements and accomplishments needed?
Right. So what I look at in the end is I look at what is the level of accomplishment in relationship to the technical complexity. Some of these projects are harder than others because some of you are stronger programmers than others, and I would like everyone to have some success with this. But so if someone does one of the easy projects, I'm not telling you right now what the easy ones are. If someone does one of the easy ones and kind of does an okay job, then they're not going to get as good a grade as someone who does one of the hard projects and does an okay job with that. I will also then look at the individual team members and adjust it by that, because sadly it often happens that there is a project with 3 or say 4 members and one of them does absolutely nothing, and that wouldn't be fair to give that person the same grade as everyone else. It's easy for me to tell who does what because I have the issues and I have your hourly reports. And so it is, of course, a subjective thing. In the end, if I just love something and think it's great, then I say, well, that's my A+ project. So make sure that I love yours. Yeah.
So for the Android project, does it really matter that much if you have an Android phone?
You can use the emulator, but it is awfully nice if at least one person in the team has an Android phone, because it just demos so much snazzier, and it gives you a feel for what's reasonable. Because that's It's of course a crazy idea to do UML diagrams on the Android anyway. The whole idea is to for those people who want to do this to learn a little bit more about Android programming in a setting. And in the end, one of the questions that I'm going to be asking you is which design patterns did you use, for example? And then that'll be interesting. You'll see then on Android it's all different than on Swing, and then you have something to talk about that in the final presentation. So I am not expecting a super usable UML editor on Android. I want to see what can be done. What is at all reasonable? On a tablet, it seems more plausible, right?
Yeah.
So if someone
It's too small.
actually has a tablet, or at least get a big a big phone. Yes. See if you can pick up a tablet somewhere for $90. Yeah.
How come you don't also provide the option for a Apple app?
Because Apple, for whatever reasons, doesn't want us to use Java.
There's no Java.
And for someone to learn like Swift or Objective-C and do all of this stuff in 6 weeks, I think that's too much. So, no. And if you already know, what's the chance of having 2 other team members who already know? And then that would not be a typical student team. So that's where it is. That's also, you would really say if you wanted to do something like this in a modern way, you would do it in JavaScript, but same thing. So we're limited to what you can do with Java.
Java effects, that's just the more modern version of Swing.
Yeah. Just Google for it. It's more modern. It's prettier. It has effects. It's actually pretty nice for drawing. It would probably be a lot easier to do a lot of the things with Java effects than it is to do them with Swing. So I think that would be kind of an interesting project. The issue with Java FX is, of course, it is a desktop technology, and not. I mean, how many people still do desktop development?
Actually, I feel sorry.
Yeah.
I feel a little bit heavy because you have to draw the graphs on Android, the UML diagrams. If you want to draw that on Android, it's kind of like heavy.
No, I mean I have all the drawing code. You just have to translate it. I mean you have the existing Violet application. It's not that you start from scratch. So you have a very large amount of code that does almost everything, and so part of it is that you're going to be having to read a whole bunch of code, and that's by design, right? So I want people to be able to read code, and that's another thing that every once in a while I run into someone who has like the first internship or they just got hired for in the first job out of college, and they're shocked and they say, they put me on this project and say, fix this bug. And there's 50,000 source files. And now what I'm supposed to do? And so I say, well, what did you expect? That they make you write something from scratch? Say, oh yeah, we just hired you. Start writing this new program. So that's never how the real world is like, right? You always start with existing code, then you have to punch and change. So I'm giving you some existing code, and you have to do something with it. That's the whole idea. See what you can harvest from it. And the code is complex, but it's not super complex. It's not something that would be beyond your capabilities. I know that because I've run similar projects before. And people, in the end, they've always come up with something that exceeded my expectations. Yes?
For the one, can we use the open source project from GitHub or with only use iOS?
For the what?
For the first project, can we use like some existing open source?
Okay, no, that's an interesting question. So, like, if there is someone who's already done a UML diagram drawer on Android, I mean, you can read through the course, but you shouldn't like fork that and
I'm not gonna use all of them. Like, there's a drawing box.
okay, you could ask me that question. Yeah, and that's actually a very good thing that you bring up. So if you want to use like something else, then and if you're at all in doubt on whether that's legitimate, just send me a quick email saying, here's what I would like to use. Is that okay? And then I'll have a look at it. And if it completely replicates the project, then of course, then I would say that's actually bad. But as an example, This one thing that where I say, use these text descriptions like you've seen in a couple of these tools to make Violet draw from the text description. What then happens is you make a text description and say this class extends that, this class extends that, and so on. And then you have all of these boxes, and you need to lay them out somehow because that's not a part of the text description. There are existing libraries that help you doing that layout, and I would strongly recommend that you use one of those instead of reinventing that particular wheel. And so for those teams who do that, I will tell you how to find those libraries and say you just need to pick one of them, and that's perfectly fine. So, but even if it's a closed set of libraries that is orthogonal to the task that you need to do and it's just there as a utility, then that's fine. If there's someone who's done an open source project that's exactly what I'm asking you to do, then we'll have to figure out how to navigate that. Other questions? Yeah.
For the collab Violet, the diagrams, do you need the UML diagrams and sequence diagrams, or what kind of diagrams do you have?
I would say, in this case, the class and sequence diagrams, that would be what I would expect. If you get more diagrams done, if you have an elegant framework that manages to do them all, then that's a bonus. But what I had in mind was classes.
And on this, that collab Violet, so that's on a server?
Yeah, so whoever wanted to do that, either you'd have to have a server somewhere, or you get one from Amazon or something, or I would have to get one for you if I can staunch one up somewhere. But what people usually do who do this kind of stuff is they apply for some AWS. Well, I have some Google credits. I have some Google Compute Engine credits, and so I could give whoever needed to do that. And the server itself would probably be kind of a homegrown thing because it's not like a web server. It has to receive messages from one and then broadcast that to a bunch of others, and that's probably easier done with just something homegrown. I can give some starting code for that. And then the way that would work is one person would probably be in charge of the server, and two people would be in charge of the client. All right. If you have other questions, just put them on on Piazza, and then we'll get through them. Other housekeeping, I have given the solutions to the homework, so they should be there, and I've given it to the grader. So let's keep plodding through chapter 6 here. All right, abstract process, we did this. We looked at that. Okay, so for some reason, I have a bug here with the pre-formatted text. I'll fix that. So last time we talked about how this highlighting, this selection thing worked, if you remember. And so what we had is we had like this car. And when it was selected, then it painted its interior black, and if it wasn't selected, then it left it white. The house the same way. So each shape somehow had this way of selecting itself. And I know it's unbelievably hokey, but it was just to get us started with this concept of an abstract class. So the idea was that you had this abstract class selectable shape that I wanted to have something that has some actual stuff in it, so it has the selected instance variable in here, and these two methods that toggle it. And then these two shapes here inherit and they go from there. So a better way of doing selection is like this, where, and it's still hokey, but there's a point to it that you'll see in a minute, is to say that we can make any shape show up as selected if we kind of fatten it up. And the way to fatten it up is what I have here, unfortunately not nicely broken. You call translate, which to shift it by 1 pixel to the right and 1 pixel down. You then draw it. You do that again, and then you go back to where you had before. And then that way you get like a fat shadow of the thing. And it's kind of nifty that you can do that by calling existing methods, because both translate and draw are existing methods of the interface. So looking again at the UML. So translate and draw are defined up here in the scene shape interface. And so we can now push this highlighting method down into the selectable shape class. So let's look at that. And so the method was called draw selection. You see it here. So draw selection calls translate, draw, and then translate back. It's always combined with another call to draw. That's why there's only 2 draws here, where in fact the line, everything's drawn 3 times. So this is now a method in selectable shape. Selectable shape is an abstract class. Now let's think about where's translate defined. Yes, so it is in the scene shape interface. The scene shape interface says void translate double dx double dy semicolon. It's an undefined method. Right? I'm not defining it in selectable shape either. So if you look at the UML diagram again, so now I have draw selection in here. So I've moved it up. It previously was here and here, so I've moved it up here. And it calls translate, which is defined up here, and into draw, which is defined up here, but it's not implemented. So my question is, how can it work? So back to here. So here now I'm calling translate. It's not defined. Wouldn't it have to crash? I mean, how can you execute a method that's not defined? Yeah.
Is it because since it's abstract, it's not associated?
Yes, that has a lot to do with it. So we will in fact never run this method on a selectable shape. Right? There is no selectable shape. There's no selectable shape object. You can't have an object of an abstract class. So when we run it, say, on a house shape, then on a house shape, translate is defined, and it'll call. So it's always worth remembering is that it's the same thing as saying this dot translate. And so this, when we call it on a house shape, is a house shape. Then this dot translate will pick the house shape's version of translate, which moves whatever some coordinate way. And it'll be fine. The same thing with this dot draw. It'll then call the house shape's draw, and it'll work fine. So even though the methods are not defined at this level, I can, in anticipation that they will be defined later, I can use them. That's kind of a cool thing, right? Because it means that I can take my simple operations, like translate and draw, I can compose them to a more complicated operation, even though they're not yet defined. That is so useful that there is a pattern for that called the template method pattern. So the draw selection method is what's called a template method because you can think of it, it is a template for the real draw selection method, so to speak. But it's fully formed. All one has to do is plug in to what it really means to translate and to draw, and then it works. So the pattern says that when you have an algorithm that's applicable for multiple types, that algorithm in my case is drawing the selection. And if the algorithm can be broken down into primitive operations, the primitive operations in my case are translate and draw, so that the order of the operations is the same. It's always translate, draw, translate, draw, translate. Then I can go to town with this pattern. So the key thing that makes the template method pattern characteristic is that you can specify an algorithm as a bunch of primitive operations. So as another example, you can think of that a sorting algorithm has always something to do with comparing and swapping. And so you could use the template method pattern there by saying, I don't know what it is that I'm sorting. Is it a linked list? Is it a whatever? As long as I can compare and swap, then you can write the algorithm and then later say what it should actually mean to do the comparing and what it should actually mean to do the swapping. So the solution then is as follows, that you define a superclass that has a method for the algorithm. And in our case, that superclass was that selectable shape. This guy here. So this one, you actually has the algorithm in here. You then implement the algorithm in the superclass, even though the superclass is abstract, by calling into the primitive operations as required, even though none of them exist. You don't define the primitive operations in the superclass, or maybe you define them with some default behavior. And then the subclasses define what the primitive operations are for themselves, but the subclasses do not do anything with the algorithm. They inherit the algorithm. So in our case, that would mean that the subclasses do not mess with draw selection. They just pick that up from the superclass. That's what's called the template method pattern. So I don't think this tells us anything right now. So here is the little table here that shows just what I said, that the abstract class is selectable shape, the concrete classes are the various shapes. The template method draw selection is defined in the abstract class, and it relies on these two primitive methods that don't exist in the abstract class, and they are supplied in the subclass. So that's a really powerful thing that says how you can push as much behavior as you can up into the template method. All right. So on to a little bit more drawing. This is very Java 2D specific here. You've already seen these path iterators in the homework, and so you know that Java 2D has this complex drawing model. One of the things that Java 2D has is called a general path, which is a sequence of shapes. So you can take a general path, you can append individual shapes to them, and then you can draw the entire path. Why didn't I tell you before? So assume you had known about this class last week, what could you have done with it? Yeah, you could have used that composite shape thing much, much easier, right? Because all you would have had to do is toss them all into a general path. The general path is a shape, so therefore it has a shape iterator. So that's why.
Is that actually very similar to the composite path?
Yeah, it's the same thing. Yes, so you could have done a two-line solution to the homework. So if anyone did that, then I'll be impressed. And so you could absolutely have done that. You could could have tossed them into a general path and made use of the fact that it has a shape iterator, which is of course implemented exactly the same way as what you have done. It iterates over each of the individual paths. So now I've made myself another class called compound shape that that uses a general path that contains a bunch of individual shapes. I have a bunch of methods here. The draw method will simply draw the general path. There's an add method that adds an individual shape to it. There is a contains method that also makes use of the fact that a general path has a contains method. And we just use that. So instead of having to figure out whether the house contains a point. So the containment test is always what's needed for saying if the mouse clicks somewhere. Click here with the mouse, and then I want to drag the thing. And so by using the general path, it's actually kind of nice. If I click here, then that'll be outside the shape. Whereas I'm sure that in the previous version, I just took the bounding rectangle off the whole thing and checked whether that contained the mouse. So I can have finer grained control by using this more complex thing that someone else who's an expert in graphics has provided. So the translate method, for that you need to know a little bit of graphics, and so I'm not, this is one of those things where I just give it to you and say, you have to call transform and with some matrix like that. If you had some linear algebra, this might make sense to you, and if you've never seen this before, just take it on faith. There'll also be a bunch of things like that in Violet when you look at the source code where it does something with these transformation matrices. If you ever hit upon something like that and you need to know something, if it's important for you, put a question on Piazza and I'll give whatever information you might need. But maybe that'll motivate you when you do take linear algebra, but there actually is a reason why they make it take it. So then in the house shape, we just extend compound shape, and our house shape has become completely trivial. All I do is I assemble my different shapes, call add on them, and that's it. All the methods are now taken care of by one of the superclasses. So now we're beginning to have what's called a framework, where it's now becomes really easy to add any other shapes simply by providing a constructor that does the same.
Is framework also
Well, a framework is something that where a lot of the expertise is already contained in some superclasses, and you provide subclasses that are there for your special problem domain. So what you will find out when you look at the Violet source code, for example, that the Violet source code has two layers. There's what's called the framework layer that has general purpose stuff that knows about moving nodes and copying them and joining them by lines and so on, but it knows nothing about the specific UML shapes. You could do other things with it. So one time I had a student use that framework, and they would come up with all sorts of other graphics editors, just not UML editors. Like there was one who did like something that architects use to show now chairs and plants and stuff get displayed and things. And so someone did like a flowchart editor out of them. So that was a nice set of projects too. All right, so here now you can see how we're layering the relationships where we're saying that here we have this interface has no behavior at all. The selectable shape just has this Boolean flag. The compound shape knows how to collect individual shapes. And the house shape does essentially nothing. Has no extra methods, just a constructor. So this kind of layering of responsibilities is very typical for more complex systems, and it is where inheritance shines. You can build this hierarchy where you add more and more functionality. you want to talk about this? No. All right, so I'm just going to tell you when you encounter this in the book. There is a way that you can call. Okay, so let me back up. So first of all, you know that it's impossible to access a private feature of the superclass. The superclass is no more public than any other class. There's a good reason for that, actually. At one point, when people first started designing these object-oriented languages, they said, well, if you extend a class, if you are a subclass, then you are not like everyone else. Why shouldn't you access the private features? There's a much closer relationship between the super and subclass than between general classes. But then they realized that people would form a subclass just to gain access to the private features. They had no interest in actually inheriting, they just wanted to muck with the private features, and then made a subclass. And so then it was realized that since inheritance is open-ended, anyone can extend that for encapsulation to work. Something in the superclass has to be private to everyone. But they still said, well, sometimes maybe it would be useful to do this anyway, and they started with something called protected. And protected means the subclasses can access it. And the consensus after 25 years or so of trying that is that protected is a mess and you shouldn't. So some people say maybe it makes sense to have protected methods. But there's so few of them. If you look into any API, it is rare for people to have done that, and for those few times that they did, it's probably not worth it. So the only benefit, or the only reason that we still worry about protected is that it's on certification. So you can read through that in the book, but I don't care about protected. Just don't use it. So as long as you don't use it, I don't care about it. So I want to go through a couple more hierarchies that you're going to be using to again drill down on this phenomenon that you want to be able to layer classes to have more and more functionality towards the fringe of the inheritance tree. So in Swing, the hierarchy of Swing components, buttons and sliders and panels and all of that, starts with a class called Component. Component has, I think, like 200 methods. So it's a huge class. So it has things like get width, get height, get preferred size, set background, whatever. It has a bunch of subclasses. The one that's most important is called Container. And Container is a component, and it can do one thing. It can have children. So like a JPanel is a container. Like a button can't really have children. Right? It wouldn't make a lot of sense to have like a button inside a button. But a panel can. So yeah, we have component, container, and now it gets a little ickier. Because component and container actually don't come from Swing, they come from the toolkit that precedes Swing, called AWT, the Abstract Windowing Toolkit that's now 20-some years old, and nobody uses it anymore. I mean, there's still people who write Swing apps, but the AWT was just there. But they figured they could repurpose those things for, I don't know, they just did. And so they said, well, we'll then have JComponent extend. Well, this is weird, right? JComponent extends. So JComponent is the base of all Swing components. So all of the Swing components start with J because there's already this pre-existing hierarchy. There's an AWT button that says one button, and that no one uses anymore. If you want to know why, write a program with one. And you'll see. I mean, it looks as old as me. And so anyway, when Swing came along, they said, okay, we'll keep the basic stuff here, and then we'll add all of our stuff here below. So these are all here J components and like buttons, like buttons, menu items, and so on.
the J components are containers?
Yes. And so that is the weird thing that I wanted to briefly point out because there's a story behind that. So what they really should have done is they should have said, well, J component should be a subclass of component, and J panel should have been like a subclass of container.
Is container abstract class or?
Yeah, those are abstract classes. So that's what they should have done, and they should not have done this. But it doesn't work because, of course, JPanel also is a component, a J component, because it has all the swing goodness. There's a whole bunch of swing stuff that's not part of the old-fashioned component. So the component has 200 methods, and J component adds another 100 or so swingy methods that don't exist in the old world of JWT. So what they should have done is they should have done this diagram where JPanel is both a container and a J component. Why didn't they do it?
Why don't they just implement this as an interface?
Oh, okay, that's a good question. Why don't they make component and container as interfaces?
I mean container interface.
Well, container inherits a whole bunch of useful stuff from component. So,
But the J component can directly inheritance from component.
yeah.
I mean, we can make container as an interface.
So their thought was, we can't make any of these into interfaces. They have hundreds of methods. This was before there were default methods. And so that you can't have an interface with 200 methods. No one is ever going to implement it. Who's going to implement 200 methods? Right? That's not going to happen. And so they said, so we have to make them classes. And so then why didn't they make JPanel extend both J component and container? In Java, you can't do that. In Java, a class can only have one superclass. Why? I mean, you have two parents. Why can't they?
Last time you said that actually all the information from the superclass and subclass are in one object.
Right.
It's hard to differentiate.
It is, in fact, hard to do. In C++, they try it. So they say, okay, we'll have this subclass object, then we'll try to pack superclass 1 part, superclass 2 part, and then we have the subclass here. And then when you now need to deal something that's known as a superclass 2, well, then you can just have like a pointer to here, and from here it looks like a superclass 2 object. But now if it's superclass 1 thing, then it looks really confusing because now the object is cut in 2 parts. And they try it, there is a way where you use what's called virtual base classes to deal with that, but it is so complicated and so rarely used, and that it was just in the end abandoned as a bad idea. Now, other modern languages such as Scala do try harder to make this kind of stuff work. So the idea of having multiple super things, in Scala it's not full-fledged classes, but what's called traits, they're slightly different, is not completely dead. So you may still run into a programming language that will do this in a better way than C++ did. But in Java, the whole idea of Java was that Java should be simple and predictable. That's actually something that may be a little bit lost in history. When Java was first created, it was created as what Gosling said, a blue-collar language. It was not meant to be a fancy-pants academic language. Otherwise, it would have looked like an object version of Scheme. So it was meant to be a language that any old programmer, whether had a college degree or just had a little bit of self-taught experience, who knew some C and C++, would be instantly at home. And that worked really well for the first 6 or 7 years until things like generics came in. Now we have lambdas. And so every language, of course, will over time accrete a whole bunch of complexity. And then it gets really complicated because you have backwards compatibility. So all the new features, they have to fit in what the old features already are, and the language gets more complex. When I first wrote that book that I'm now rewriting, one of the goals that we had here in the department was that every student should come out of, when they have their bachelor's degree, there should be one language where they know everything about that language. And so Java was that language. Until Java 1.4, that was a feasible goal. You could know everything about the language and a lot about much of the library. I mean, of course, not Swing as something, but the basic util library. So Java Lang and Java util, that was a reasonable goal at the time. Then generics came and that goal was blown out of the water. And today, de facto life is probably, is there any language that you can know everything about? I challenge you. Have you looked at ECMAScript 6? I would think that there is no one person who knows everything about ES26. No, but see, that's the thing. It used to be. So the last language where I can say with confidence that I know everything about, absolutely everything. I've read the entire spec, and I could, without any question or doubt, tell you everything is C. So C is dead simple.
That's what I was gonna suggest.
And then C++ got incredibly complex. There's absolutely no one who knows even half of C++. Strustrup would cheerfully admit that you could ask him 100 questions where he wouldn't begin to know what the answer is, and he would have to dig into the spec and try to figure it out. Then Java came along, and it was much simpler, blue collar. So that was a design goal of Java, to be really dead simple to use. And it still drives the design, that there are some like magic things that they don't want to put into Java because they say, oh, it would be too hard to understand for the blue collar programmer. That it would be too much like magic and would be unpredictable. And so they stay away from adding those things to the language for that reason. And you can't argue with success, right? It is one of the of all planned languages is probably the most successful. So anyway, so I wanted to say this just to point out this weirdness that JPanel and JButton extend container, and it is in fact possible to put a JButton as a child of another JButton. I tried that out once and I don't remember what happened. I think the inner one just doesn't show up. But it is possible. All right. So another thing that's actually interesting about Swing, and that I'm a little sad that now is going away, is that Swing is quite cool in that you can change the look and feel of it, which at the time was a totally novel idea. So nowadays, of course, you know how to do that in the web with CSS style sheets, but Swing had a way of doing that, and so it has, in particular, this one look and feel that I've used for a couple projects that I really like, called the napkin look and feel. And so the problem that they wanted to solve was this, that when you make a demo of some project that you're working on, and you're just there in phase one, and you're interacting with the customers, and so you get the task to whip up that demo, then the marketing guy brings that demo to the meeting with the customers and shows off the 3 or 4 things that you kind of hacked together. And what do the customers say? No, that's not even what they say. They say, "Oh, great! When can we have it?" And so now the expectation has been set that it's almost done, and it's not even going to cost very much because if they did all that work in 2 weeks, this is clearly going to be delivered under budget. And so this guy came up with this way of making the appearance of the buttons and the text fields and everything that you have in a user interface as if it was drawn by him. All you have to do is change the look and feel to this napkin look and feel. And then when you demo it, it speaks for itself. It's clear that this is nowhere done. So I want to have that in CSS. So like for web application, because it is a cool idea. So, and it speaks to the flexibility of Swing that they could do that. Of course, that was not their use case. Their use case was that they wanted the same interface mimic what you could do on the Mac, at that time, and Windows at that time, and various Unixy systems. And so a JButton will just paint itself according to what it should look like. So nowadays, that has completely gone out of favor because it was Windows' fault that their buttons became ever more complex and unsupportable. And with every version of Windows, the buttons were more throbbing and moving and glowing and whatever. And so they definitely look different than what we could do by just painting them. All right, so we've beaten this one here to death. There's another hierarchy that I would want to talk about because you will likely need it, and that is the hierarchy of geometrical shapes. So in Java 1.0, you had points, rectangles, and polygons, and that was it. Then Java 2 came up with a very nice 2D drawing system that has what you want to have in a 2D drawing system. And so you might say, this is all very Java specific, but actually, if you learn to use Java 2D, and later you have to use HTML Canvas, it's all the same stuff. And so it is super useful to be able to know a little bit about these quadratic and cubic curves. And not everyone, but probably a few of you, when you get into the weeds of some of the violent code, you will run into that. So for example, if you need to draw an arrow like this, there is no primitive for that, right? There's nothing in HTML Canvas that says, draw me this arrow. So what you have to be able to do is say, okay, what I really want is I want two curves, and quad curves will do, I think. That the one starts off horizontally like this and meets somewhere in the middle here, and then the other has the same tangent, and then has a horizontal tangent here. And this is one of the few times that you might need just a tiny amount of calculus to figure out what that curve is. Generally, I can't say that I've ever used my calculus in programming, but here, I think it might have. So anyway, so you have this model here. The way it works here is that you have this shape interface that you now know and love. You have these subclasses of shape. So here they are. You have line 2D, rectangular shape, where all of these things, you have rectangles, round rectangles. Ellipses are not really rectangular, but they have a rectangular bounding box. So, box, and you have the ellipse sitting in here. And an elliptical arc is just some fraction. It's just some fraction of an ellipse. Something like this. That you might also need if you have used for a specialized arc. Here's our general path, which we've just seen. So rectangular shapes are something that you need to worry about a lot because just any time you deal with graphs, the nodes are either rectangles or they're close enough that you can approximate them by the bounding boxes. And there are a whole bunch of useful methods in rectangular shapes, such as get center x, get min x, get max x. And you will end up using those things a lot. When you do the same thing in FX or in the Android library, you'll be looking for the analogs of this. So the more methods you can have, the easier your various formulas come out to be. So for example, you have your rectangle here. If you need to place another rectangle next to it, then you can say, okay, it's get max x plus some gap. And then you don't have to do an ugly get x plus get width. So you will soon enough end up using these things.
Next question.
Yeah.
Why do they implement the coordinates in the negative y?
Oh, that's a very good question. Yes. So his question is, why does the coordinate system look like this? And it is one of my pet peeves too, I must say, because it's different from the coordinate system that we've been using for a few hundred years that went like that. And it's gratuitously different. So each time you have to think about it that the y-axis goes kind of the wrong way. And after a while, this becomes the right way, but it's still no excuse. And so I believe they did this because originally at some point someone was thinking of a bitmap screen where you address the individual pixels. And they kind of said, they just looked at them as if it was an array of pixels, and that's where this coordinate system came into being. Nowadays, of course, you don't think of the individual pixels anymore. But when I bought my first computer, I counted those pixels. I had a computer with 640 by 200 pixels resolution. I mean, nowadays you wouldn't even get a phone like that. But
So they did it because that's how we read, I guess?
yeah, because they
Maybe
said,
actually-
this is the 0, 0 pixel, this
Yeah.
is the 0, 1, and then this is the plus 1, 0.
Right.
Two-dimensional already.
They looked at it as a two-dimensional, right? But it's not really a good excuse, right? How hard would it have been to do it the other way around? But someone started, and then the next guy's copied it, and it's been like that forever. That happens a lot. I mean,
But wasn't that actually 2D is a little bit different because they use units to replace the pixel?
well, now they use units, right? But if you look at Swing, it's all pixel-based, and the systems that preceded it also are pixel-based. So nowadays you kind of snicker and say you still use pixels. Like if you use JavaFX, in fact, you'll run into that conflict. They're using pixels when they really shouldn't be using pixels anymore. But no, that's how the systems work. And interestingly enough, there's a system called PostScript that is used in high-end printers, designed by no one else but James Gosling, the same James Gosling who designed Java. And PostScript has a coordinate system that looks like that. The lower end of the paper is the origin, and the y-axis goes upwards. So Gosling didn't want to have anything to do with that nonsense. And the PostScript manual, in fact, says, we're using this coordinate system because that's what we're using for hundreds of years. And we're not going to be distracted by that momentary craziness. All right, so there's this one weirdness of the float and double subclasses that we talked about a little bit, and the book goes in there in some degree. And I don't want to go through that sordid history, except I want to have one quick look at one of them. So here we have the rectangle 2D class. Here we have the rectangle 2D.float subclass. And you can see that it has instance variables of type float for efficiency, just in case you have 10 billion rectangles. You have these methods here, get x, get y, get width, get height, and so on. And so on, there's not very many methods in here.
They're both be public.
Oh yeah, that's another thing. Yeah, don't look. Yeah. Yes, they're public instance variables. So you can actually assign them. The thought was this thing here, is such a lightweight thing, and it's never going to change. And so, as a practical matter, I think there's nothing really wrong with something like that. If you have a class that will never change, you might as well make them public. But I can't say that in public. So we're never going to use these public fields.
My question is actually about the static class.
Oh, why is it called
inner
static?
class. Yeah.
Well, this is an inner class weirdness that we're not really getting into. An inner class, normally, an object of an inner class knows the outer class object that created it. And that is sometimes important, like when you have an inner class that's an iterator, and it needs to know the outer class stuff that it's iterating over. But in this case here, we're not interested in that feature. We do not want a rectangle 2D.float to have an extra pointer to something that created it. We just want it to happen with these 4 instance variables. So that's why it's called static. Yeah, why static anyway? No, let me not get into that because I want to get to the point that I want to make. So the point that I wanted to make here is that when you look at the contains method of the rectangle 2D class, which has no instance variables, it's just there to have a bunch of methods and it holds these 2 inner classes. So rectangle 2D by itself, no instance variables. The way that contains works is it calls get x and get y, and get width and get height of the float or double subclass, and then it checks whether x and y is contained inside that rectangle. And notice that this is the template method we have. Contains says, as long as you give me primitive operations, get x, get y, get width, and get height, then I will give you a containment out of them. Rectangle 2D doesn't have any of these operations. It doesn't have a get x, get y, get width, get height, because it has no instances. It has no variable sitting in there at all. It relies on the subclasses, rectangle, freedom, float, rectangle, freedom, double, to provide this. So that's the template method at work. That's what I wanted to show. All right. We're not going to go through the exception class. You can read that yourself. And I'm not going to go through the last thing because I want to get a little bit of time built in so that next week we can mess around with some Android programming so that all of you can at least write on your resume that you know how to write Hello World in Android. I will give you instructions what you need to install. It's not a complex install, but it takes a long time. So you need to install it before we come to class. We'll have a lab next Tuesday. Any final questions? Yeah.
About the project groups, when do we have to let you know by when you're
By Friday at 1 minute before midnight.
this Friday?
This Friday, yes, tomorrow. Because you're going to have to deliver something next Wednesday, so it can't be next Friday. Yes, this Friday. So I mean, and if you don't know anyone in class, just say put me together with anyone. But I would like to work on these things. And then I will try to eyeball, what grades I have, and try to put you into. So my goal is to have teams where everyone has about this, has similar abilities. I don't want to have a team where there's 2 people who are really good and 2 people who are much weaker, because then it's very hard to get a good team dynamic. And I'm perfectly happy to have teams where it's people who are not as strong, and I'm not expecting them to deliver something that's as perfect as that what the very strong guys do, but I want them to learn to work in a team. That's the objective really is to learn to work in a team and also to experience how frustrating it can be to have to do something in a team. Because let's face it, all of you would be able to do the project that we're going to be doing in these 6 weeks much faster if you could just do it yourself. So you're going to be seeing more of the pain and less of the benefit of teamwork. But teamwork is super important, something that employers always tell us we need to do more of. And so this is one of the classes where you're going to get that experience whether you like it or not. Yeah, just don't get your hopes up. Of course, you could just, every one of you, if you could just have a week of peace, you would be able to make a bang-up project out of this. And that's not the point. I'm perfectly aware of that. But I really do want you to have that experience. All right. So send me your emails as soon as you can.